So, this is Jorge Salerno.
Salerno?
Yeah. Salerno, sorry. Jorge Salerno, who's autistic. He likes monitoring things, including the cloud, including stacks of Raspberry Pis with sensors.
Everything.
And he is going to tell us how to troubleshoot Kubernetes.
Okay.
So, welcome, Jorge.
Thank you. Okay, so today it's been an intensive day for me. This is my third talk. Has anyone seen one of the previous ones? Can you raise hands? Oh, cool. So, you know SysDig. I've shown this slide before. If you're here, it's probably because you are running Kubernetes or you're applying to do so. And until we got things like containers, Kubernetes, when we had to troubleshoot and find out what was wrong, what was broken on our servers, we used to use tools like that. But then when containers came around, things stopped working. Basically, those tools, they were not aware of namespaces, of tgrips. We had to trick them. They were not working as good as they were working before. And actually, this is a real problem. I have included here an issue on Kubernetes GitHub project, and someone trying to troubleshoot, and the answer of the developers is, well, you know, like try to run bash, loop over there, do some prints, see if somehow you can get visibility of what's going on inside of the containers. We love containers for multiple reasons. Probably 4 ones to mention is that they are simple, they are small most of the times, not always. They are isolated from a security point of view, that's nice. They have less dependencies, we ship everything, we don't have to deal with messing things around. But they are black boxes. We cannot see what's happening inside as we used to do before. Or we have to break these things and install the troubleshooting tools inside, which is not the desired or the best option. That's what we are trying to fix with SysDig. SysDig, it's like a combination of all those tools you were using before to troubleshoot your servers, HStat, VMstat, NetStat, all of them, all together in one single tool, available as open source. We also have a commercial product, but that's not for today. And what we do differently is two things. It's twofold. On one side, we are able to give complete visibility of everything that's happening inside of the containers. We have managed to do that, instrumenting the kernel. We install a kernel module that basically it does capture all the system calls. We copy them into a ring buffer, and then we let user space process to pick the data from that buffer, and suddenly we have everything to a user space where we are more comfortable mangling things around, grouping and segmenting and everything. So yeah, we install the kernel module, the agent, this kernel module captures everything. We move that into the user space, can either be a daemon or we can even run inside of a privileged container because we need to do an insmod to install that kernel module. That kernel module builds dynamically using the KMS if we don't have a binary. SysDig is included in the distribution that you are probably using. If you're using Apple, we can still open the capture files, but we cannot capture in Apple. And we dump everything into a file. And this approach basically has some benefits, has some advantages. We discover, since that process, the SysDig can see everything happening in your host, we can automatically discover every container you run. So there is no need to instrument to configure that, oh, I have a scale-up replica or something, and then there is a new container, or there are less containers, and I need to reconfigure things around. Now, forget about that. No instrumentation, so there is no need to install an agent in every container or funky things like that, and full visibility. The con, or the thing that you have to pay the trade-off, is that you need to install a kernel module. If you haven't been into my previous talks, I have mentioned this. The reason I'm going to answer this, because probably otherwise will be a question that you will be making me at the end, is when we started SysDig, eBPF didn't exist as it is today. So we had no chance to use that. Has been evolving, and for a period of time it had some limitations. So for example, we had to copy everything on the buffers, and eBPF had some limitation on the amount of data you could copy out from the system calls. There are some limitations. Those, they have been solved, so maybe in the future we change. Then the other problem with Kubernetes or with containers and microservices is that we don't have like single hosts and 1, 2, 3, a number of services running inside. No, like we have a scheduler and it's moving things around all the time. So when we need to filter, we need to organize things, we would like to get the view like as close as this as possible, where we can say, okay, so I have my Cassandra service, or I have my Redis, and I want to filter things by that. Well, the other very cool thing we do at SysDig is we talk to your container orchestrator platform. So either if it's just plain Docker or Kubernetes, OpenShift, DCOS, Mesos, and even a bunch of other platforms, we can talk to them, understand how you are deploying containers, how you schedule them, how they are related to each other, and use that information to filter. Because at the end of the day, what SysDig can do is capturing all these events that they are the system calls with some context, so we can understand better what they are doing, filter them, and run scripts to change, generate reports, and find out what these things are doing. We can do this live, or we can dump things into a file, which is similar to TCP dump pickup files. We have container support, I have mentioned this before, and we have command line interface, but also we have a courses interface, something similar to HTOP. And this is basically everything I have for slides. Now we are moving into the dangerous part of this presentation, which is the demo. I have a very cool use case of how you can, or of a story that happened to us when running Kubernetes. I wanted to fully show it live, but there was some last minute problem with the network because it depends on something external. But no worries, because I have a system capture and I'm going to be able to show you exactly the same thing. But first of all, we are brave and we are going to show you something live. So let me move this. This terminal background, you can forget about it. It's in notes, so I don't forget the things. So basically, I have here a Kubernetes instance. It's running different containers. I install everything, just pulling the different Docker containers. And first of all, I want to show you how we can leverage, how we can use SysDig to understand how Kubernetes works. And I'm going to illustrate this with an example, a very simple example of a service. So first thing I'm going to do, I'm going to create namespace, which is a critical app. Very, very, very critical. That's why I'm running it on Kubernetes. Then, inside of this namespace, I have a service with a deployment, and I'll be deploying 3 replicas of an Nginx container. Simple as that. So let me deploy that. And let's see. Okay, it was catch. So that's running already. Cool. So one of the things it's very interesting, or that Kubernetes does for us is managing the load balancer. I'm not going to discover anything new for you. So we deploy a service. Kubernetes places a load balancer in front and distributes the traffic between the number of containers we have there. There are multiple or different strategies. In this case, I'm just using a load balancer on one fixed IP address. We can do this with DNS round robin, but in this case, we keep it simple. So we know that our backend service gets that IP address, .241, and I got these 3 different endpoints, my Nginx pods. What I'm going to do now is to launch one client just with curl, and I leave that on the background, and I'll open a new shell so we can follow up. Okay, perfect. So this is my client. So now, if I do curl backend, this works. So basically, returns the default homepage for Nginx. Cool, not a surprise. But do we really know what's happening behind the scenes here? We can imagine if we read the documentation, but the first step to get familiar and to use properly a troubleshooting tool is to understand how the infrastructure really works. So what I'm going to do is to leverage SysDig for that. I told you already. So one of the things, very interesting things of SysDig is that we can use Kubernetes entities or objects to filter out things. I'm showing here the different labels we understand from Kubernetes. If you are using custom ones, we can also filter them, but these are the defaults. So pods, namespaces, like the usual stuff. What I want to do now is show you the course interface. So I'll be using SysDig. Actually, I wanted to show you this. Basically, what we do here is to tell SysDig to connect to Kubernetes API. So we know how things work inside. So these are all the processes running in my machine. This could be HTOP. Well, it's not. Because if we see here, this is probably one of the most interesting sections. They are different views that we have pre-built for you. I showed some of them before, talks like using tracers or using this for security. But if you have a look at it here, we have pre-built views for different orchestration tools. In this case, we will focus on Kubernetes. So if I click here, I'm going to be able to see the different namespaces I got. So I have my critical app and also kube system, which is the internal namespace. Well, let me stop here. Oh, I did close this. I could get this with using kubectl. What it's interesting here is that I'm able to show you some metrics, CPU, memory, file, network, aggregated by that information. So I could see what was the memory usage for the namespace or the network usage. In the same way I do this for namespaces, I can do for deployments with my backend deployment or for services. And what's interesting is that this is like a tree. There is a hierarchy here. So if I go into my backend and I hit enter, automatically I go to the level underneath and I see all the pods that they are running inside of that service. All the time I'm showing the metrics. And if you pay attention here on filter, I can see the filter that SysDig is applying. So this very same filter can be applied on the command line. So one of the things I want to show now is, as I mentioned before, I want to understand what really happens behind the scenes when I do curl backend and how all that connection is handled, all the load balancing and everything. So what I'm going to do is to open SysDig with a few filters. In this case, I'm using the command line interface. So -K for the Kubernetes API. Then I'm using event type open to see open syscalls on files. And then I want to see every file that it's in /etc. And also I want to see everything that's in the client path. So if I go back here and I do curl backend, automatically I see all the files that they were open in my client container under /etc. Remember, I'm able to see this from outside, okay? SysDig is running on my host in this case. Okay, that's cool. I can see, the different open parameters and everything, but I'm curious and I would like to know what it's actually that I'm reading for those files. And in this case, what I can do is to leverage on SysDig chisels. SysDig chisels are some Lua scripts we got that we feed all the system calls, all the events, and all the related information. And with those Lua scripts, we can reformat the information, aggregate it, manipulate it, and, for example, generate a report or format the output. So I'm going to do C echo FDS. This is the right command. Let me double check. Now I was doing spy file. Well, would be the same thing. Okay, so if I run this command again, nothing happens. So probably I'm doing something wrong.
Space after the C.
Check. No. Spy file. Yeah, I will be using echo. I don't know why I have on my notes. What? What's wrong? This is the first steps of the demo.
Remove the Kubernetes filter maybe.
There we go. Now this is what I showed you before. Well, otherwise I will move into the next command I wanted to show you. What? Anyway, I'm not messing with this. The other thing I wanted to show you, spy file, that should be working. If I use this other chisel, and now it's working. I don't know, it was stupid. I can see exactly what I was reading. Okay, it's very similar to the echo FDS. So when I did open NS switch, so I did curl. So curl tried to resolve that name. So open NS switch. I read that file. Then I open host.conf, then I open resolve.conf, then I read hosts. And with all of the information, I didn't read anything else under /etc. So this is a nice way to see what my application is actually reading from those files, because they could be changing automatically or things like that. Another use case of chisels. Another example I wanted to show you is spy users. Spy users is a chisel that will print everything I execute. So simple as that. Come here, execute again, and I can see how the root user executed that command. So these are the kind of things are going to be very convenient to troubleshoot your Kubernetes when you have an issue. That's the last example before we move to someone else. I'm using HTTP log, so guess what? It's going to decode system calls writing into sockets, will decode the HTTP protocol, and will show me here the request, including HTTP method or return a response code, latency, things like that. So this is very interesting, but still, I would like to know everything that's happening. So, and I mentioned before, I'm not copying everything. And I mentioned before, says they can see everything. So, okay, let's see everything. I'm going to explain you here this command. So again, I'm connecting to Kubernetes API. I'm using PK that's printing from which container is that event coming from. NA format the output as ASCII, and then I'm applying some filters, and I can already foresee this is going to fail. But and then I'm applying some filters. Now, that my notes, they were not as good as I thought. Oh, that should be okay. I'm filtering all the traffic that's network traffic with FD type, so file descriptors that they are actually IPv4 or IPv sockets. And then I'm using some Kubernetes filters saying, okay, everything on the namespace critical up, or that it's SkyDNS, which is the resolver I'm using. So if I run my command, I can see everything that was executed. So let me show you from the beginning. This is a bit complicated, but we'll go through it. So I'm just going to highlight the most important parts, okay? So we get the socket. First thing, we see that this is going to port 53, so it's the DNS resolution. And the DNS resolution goes into my DNS server, because we can see the IP there. But then, and we see that it's coming from curl. Then we see that the next message is actually coming from a SkyDNS. We read from the socket, but we open a new connection to this guy on port 4001. So we know that that guy is etcd. And what we do there is etcd REST request with this URL, trying to find out what's the IP address associated with that domain name. We do that, we get the reply over here. I'm not going to get into the details. Let me find, there we go. You see there, JSON reply with the IP address there. Then that goes back to SkyDNS. SkyDNS sends a DNS response, and then we see curl here that it got the IP address where we need to connect to. One very interesting thing, and actually I don't want to miss, is what is this 241? So if we go back to my Kubernetes, kubectl. No, this is not here. kubectl inspect backend. No. Describe. We see that 241 is the IP address of the load balancer. Okay, so what etc replied was the IP address of the load balancer. Let's go back here. We see curl connecting to that IP address. Let's find it out. 53. There we go. So, or should we even? So it's connecting to this API address, 241 port 80, but then suddenly, when we keep reading and we see the Nginx pod on this line, we already see that this reply, it's not coming from the same AP address. So this is different, 172.17.05, which is the IP address of the pod. This is tricky, this is thick. So we see the reply back, or we see the get, how Nginx gets the read, the get request, we do the write back, which arrives to curl, and curl print it. Okay, so we see how the system calls. Yes, we got a question.
Is it possible to export also traffic as PCAP out of this tool?
We don't have a way to export. Oh, yes, the question was if there is any way to export to PCAP. We don't have a way now because probably, if not all, most of the filters that you can be using on TCP/DOM can be used here already. Okay, so we did this. There was, and we saw the system calls, like all the sockets and everything, writes, reads, files being read to understand the DNS resolution. But we found out that there was some changes on the IP address. And actually, if we do IP tables, we'll see how Kubernetes has one I am in the right place. Yes. This is thick here. We have one place, kube services, where all the traffic that goes into the backend service, because the screen is too small, cannot be seen properly. But we will, if we read this carefully, we will see how Kubernetes creates a chain on IP tables that all the traffic that goes into that IP address is split in 3 different chains with some probability deterministic module to load balance between the different containers, different pods, and the traffic goes to a different IP address. Okay, that's more or less how it works. SysLake, it's very useful for this. And if we have some more time, I got something else prepared, which is one issue I experimented. And we have 45 minutes, right? So we have 10 minutes more. Okay, perfect. So this is live. This is very helpful to understand what Kubernetes is doing behind the scenes, but actually the title of this talk was how we can troubleshoot Kubernetes. And as I said before, I wanted to do this live, but there are some network external dependencies. So instead I'm bringing a capture file of an issue that happened to us. And we were running exactly the same scenario, but curl, instead of returning immediately, it was taking close to 10 seconds, waiting there, hanging, and then it was working. So what is the worst thing that can happen to us as operators of an infrastructure? That things fails? No, that's great because we can fix it. Worst thing that can happen is that things work very slowly and we don't know why. So I took a capture of that scenario and I'm going to show you how we found the problem using SysDig. So I'm moving back. Hopefully this is big enough. And what I'm going to do here is, again, open, I think you're going to hate syscalls after this talk. Open a capture file, and again, include IPv4 and IPv6 sockets, and filter by, again, my critical app on SkyDNS. And what it's very interesting here, and as you see this is going, can you still see this? Because this is very slow. Well, it's very interesting here. I'm going to go quickly. It's similar to what we saw before. We are going to see curl trying to resolve a host name. We'll go to etcd. etcd will will go to SkyDNS. SkyDNS will try to resolve through etcd, and if the entry is not found in etcd, it's going to try with different search domains, and at the end we'll see that something unexpected happens. So actually, let me go through directly to the points I want to show you. So we can see that first, my request, or the request that goes through etcd, it's very, very long. Sorry, I forgot since the beginning. Now, what we are doing differently is, instead of using curl backend, I'm using a fully qualified domain name because it works, or at least according to the documentation. If I use curl or any DNS, which my service SVC, then my namespace .cluster.local, Kubernetes offer that DNS entry by default. So by some reason, I see on the syscalls and all this tracing that we are crafting a very funny search, or we are searching for a very funny domain name. So it's probably search doing funky stuff. We'll see here. We do this request that obviously it's not going to be found. We'll do the request again, removing some parts of it. So the search domain, it's removing different parts, again, not found. It does it one more time with less, it's not found. So we might think that we are losing time. So the original problem was this was taking to execute around 8 to 10 seconds. But if we look at the timestamps from the beginning, this was 41 minutes, 39 seconds. And I'm here. I'm still 41 minutes, 39 seconds. So what's the problem here? Why this is not working? If we see already here, let me find shit. If we see already here, we start to see DNS requests that they are adding or they are appending at the end something we are not expecting. Local domain. Crazy. So let me keep searching because I want to find, and actually I want to find the last request we do here. You see, I'm trying to do a local domain. Oh, I'm already at the end. And this is not working. So that's crazy. So what happened? What it's happening here is that, let's start to look at the timestamp on the left. So we go faster. 41, 47, 41, 43. So what happened in between? Oh, I lost it.
44, 47.
So what's happening in here? Look what we can see here. So what's happening is that the Sky DNS is going to etcd, is trying to get, the DNS request is going to Sky DNS. Sky DNS identifies this request with a local domain appended at the end, and Sky DNS says, whoa, this is a domain I don't have in Kubernetes. So this must be some external domain. So let's send this out to my upstream DNS server. And because my upstream DNS server, it's not answering, so it's answering very slowly, or it's not even available, we wait for a full DNS timeout, almost 4 seconds. So this will happen one time, will happen 2 times, and will happen 3 times until libc decides that it's enough. Stop trying to remove pieces of my full search domain, and we will just try to resolve the fully qualified domain vanilla as I gave it to my curl, and then obviously will work. So this is what happens at the end. So this is a very good way to, when we have different services talking to each other, how we can get visibility of things one side, the other side. Sysdig and the filters are very convenient. And you will say, well, but this was everything network. I could have done this with TCP/DAM and with more patience using my filters. I said, okay, yes, but you want to be completely sure that what was happening on your client. So, as I showed you before, Sysdig does allow not only to filter on your network traffic, but on any file descriptor. So if I'm using the echo FDS, as I showed you before, and now I'm going to repeat it because now it will make more sense to you if I don't have the same problem I had before. So I can see that there was something appended at the end, which was local domain, that at the end we found out because it was being executed in a developer machine, and the developer had that local domain added by probably some network manager crap or who knows, and that was going or was being transmitted into Kubernetes, and Kubernetes was creating the Docker containers with that search domain appended to it. And how you can be sure that this is happening? Well, again, we know that we can use Sysdig to understand how Kubernetes is instructing Docker to create the containers. So I'm not going to use local domain here because this is not live on my example, but I'm going to use just search. So if I run similar command to the one before, but this time I'm filtering on Unix sockets. And if I try to launch a new container, I'll see how Kubernetes is using the Docker API on a Unix socket to tell Docker how you need to create this container according to the pod description. So I'm going to run this. And now I'm going to create a different container, different name, there we go. foobar container. And something is failing here again. Event buffer, contain search. Well, you will have to believe me. Well, probably there is something wrong on my filtering. I want to keep the last 5 minutes for questions. But yeah, this is the idea. If or when you leave this talk now in 5 minutes, what I would like you to remember or to keep for Helm is that you can use SysDig to troubleshoot anywhere. You can hook anywhere on your hosts. If you compare this to other eBPF-based tools, this is way more simple to use. You don't need to know exactly what kind of system call you want to hook. You don't need to code any script. Just using something similar to what could be TCP dump, both on steroids and system call aware, you can very quickly see a lot of things. Obviously, it's not as complete as it has different use cases, but you can see network, you can see file descriptors, you can see everything that has a syscall attached. And this is everything I have for today. I'm leaving here 3 links. This very same talk, it's fully explained in the last link. So if you're very tired and you want to look at these syscalls more carefully, maybe with a beer in your hand, and more relaxed, go through it. You have the same capture, so you can play with filters yourself and everything. Totally recommended. I hope you like it. We have 5 minutes for questions now.
How would I run it on another system like DCOS?
The question was, how can I run this on any system like DCOS? Well, in this case, it was a command line tool that it was installed through a package, but SysDig can be installed just pulling the container for Docker from Docker Hub. Any place where you can run a Docker container, you can run SysDig. The requirement is that it needs to be a privileged container because we need to pin the kernel module, insert it, and we need to execute in small. So that happens.
If I've got multiple machines that's running, what's the best way to correlate the multiple cache?
The question was, when I have a multiple machines scenario, how can I correlate the events or the system calls between all of them? At the moment, there is no tool to merge the different capture files. Yes, we have the commercial tool that does something similar to run on multiple hosts. It shouldn't be very difficult. In the same way we have tools to merge 2 pcap files together, you could write a very simple tool to merge this and then open. The only thing to take into account is that these files, they tend to grow very, very quickly. Remember that they store all the system calls with all the IO buffers, everything being executed on your machine. So just a few seconds on a production server can be a few gigabytes. So you need to be careful with filters to keep only the information you are interested in. But if you have more questions, send me a tweet message or anything. I'll be happy to answer. Thank you.